Well, welcome everybody. Thank you for coming all to this event today. We are here virtually gathered for the presentation of the Ottawa MCon Lifetime Achievement Award, and following will be a presentation by Emmett Proulx of the City of Ottawa, who's going to tell us all about the Protected Intersection Design Guide. So thank you so much for being here with us today. I am John Kingsley. I have the honor of being the National Capital Section President this year for CITE. I say it's an honor because I share that honor with so many wonderful people in the industry who have been here before me, and we'll get to that, I think, a little bit later. So just wanted to start out by thanking all of the organizations who have agreed to generously sponsor us this year for the 2022 calendar year. That's Stantec, Morrison Hershfield, WSP, CGH, Parsons, Novatech, Robinson, BT Engineering, JL Richards, and Dillon Consulting. We really appreciate your support, and it helps us run our programming every year. So definitely wanted to say that off the top. Actually, I suppose one more thing I guess we should probably, I should tell everybody is that the National Capital Section Executive this year will be partaking in the Cleaning the Capital program as part of the City of Ottawa. They run every year where we will be going out and I guess selecting a part of the city to clean litter and other such detritus, I guess, from the streets. So we will be doing that sometime in May. We're currently scheduling when that will be and where in the city we will be going, but we'll send out an email blast to everyone with that information. And if you want to join us, please feel free, and it would be fun. And I think the more the merrier. So I guess that gets us to part of why we're here today. And yeah, so that is the presentation of the Ottawa MCon Lifetime Achievement Award. I did notice that Dr. Khan is in the webinar now, so welcome, and thank you for coming. We are presenting it to Sean Rathwell, and Sean, you may remember, it will be the presenter of our last webinar. And we did not inform him at the time, so he did that totally unknowing. Yeah, so I'm going to hand it over to David Krieger, who nominated Sean, to maybe introduce him a bit. But I was thinking at the end of Sean's few words that he may say, I would invite everybody to turn on your webcams so that he's not just kind of broadcasting to an empty floor, so that you can show your faces, especially if you work with Sean in the past, and yeah, just kind of say, or in the present as I do, show your face and show your support and everything. So I'll hand it over to David Krieger now, if you would, David. Thank you.
Great, thank you, John, and hello, everyone. So I was honored to be last year's recipient of the MCon Lifetime Achievement Award, and I'm really delighted to introduce this year's winner, who is Sean Rathwell. So I first met Sean when he joined the region of Ottawa Carleton as our modeling team's summer student back in the 1980s. My earliest recollection is that my colleagues and I had to learn terms like belay that. Sean was in the Naval Reserve at the time. More important, Sean quickly impressed us with his always positive approach, his practicality, his forward thinking, and a willingness to try something new. And I'm sure these are traits that everyone at today's meetings will also recognize. So Sean, the citation for the award tells about your many and varied technical achievements, your academic prowess, your shaping of BRT and mobility in cities across 4 countries, and there may be more, those are the ones I know of, your collaboration with colleagues in both the public and private sectors, your articles and papers, the training courses that you have conducted and designed, your giving back to the community, voluntary efforts in CITE, CUDA, TRB, and more. So that's the technical side, and that is a lot. On top of that, I'd like to note that you've influenced many, many, many peers and colleagues here in Ottawa, across the country, and wherever your work has taken you. I've often heard from others how you've mentored them throughout their careers, people who have now achieved positions of responsibility and influence, people for whom you have set a tremendous example and shown not only what could be done technically, but also how to go about doing it with enthusiasm, dedication, and always with a smile. So with that, I hope you'll all join me in wishing Sean a well-earned congratulations. And I guess the only thing I can think of is a wave. So congratulations, Sean.
Wow, thank you, David. Yeah, until about 2 minutes ago, I wasn't certain who had actually nominated me. So thank you very much, David. It's for taking the time to do that, and to the section for accepting the nomination and presenting me the award today. John showed you that picture that we did on Sunday, but it's actually here, and very much appreciated. I've been pretty fortunate in almost 37 years of working in the transportation and transit business. I got the opportunity to work in the public sector for 15 years at OC Transpo, and be part of the leading group that developed and implemented the transitway systems and bus rapid transit, and while we don't think of it so much as an opportunity in the public sector, got to meet people from all over the world that came to Ottawa to see the transitway. And I don't think a lot of people necessarily realize that, both people like me certainly, that the transitway was considered leading edge internationally, and people literally came from everywhere. All of the continents, other than Antarctica, came to visit us, and the system that we implemented in Ottawa with the transitway influenced other systems. Brisbane, they came and saw what's here, and then they built a modern Australian version of the same thing, and it's been incredibly successful there. New York City, their bus lanes were modeled on the downtown one lane out from the curb fast acting lanes that we implemented in the 1980s. That's their BRT network today. It's been modeled on that. So, it's been
Please
exciting.
enter your access code
those
followed
sorts
by
of
the
things.
pound or hash.
Also been fortunate to be able to work in consulting and sort of transfer some of that knowledge that I learned in the first half, if you will, of my career with other clients. I'm fortunate enough to have worked on about 24 BRT planning or related kinds of projects in 7 countries, David, actually. Certainly across Canada, and worked in 9 provinces. I've worked in 16 US states, Australia, New Zealand, the UK, Nigeria, India, and China on a variety of projects, all related to transit generally. And consulting also gave me the opportunity not only to be the technical lead in things, but to take on some management responsibilities and lead groups and offices, and that can be really rewarding, or was really rewarding. David mentioned the opportunities that I've had to be involved in the industry a little bit, and with the Canadian Urban Transit Association in particular, chairing their business members committee and member of the board of directors and executive committee, and teaching the transit planning course for nearly 18 years has been a lot of fun. And then with ITE and APTA, the American version of CUDA, and TRB, getting involved in committees and initiatives there. That kind of involvement, getting involved in things and going and presenting about what you're doing, and it's a great way to meet people and to be involved and feel like you're making a difference. And I've really been fortunate in particular with the people that I've been able to connect with and be to work with. Lots of leaders and mentors that gave me opportunities along the way. In particular, Ada Khan, Professor Khan was, I went to Carleton and he supervised my master's degree. He gave me my first non-naval reserve non-musical job, researching intercity bus and rail policies in Canada as a summer student after third year. And then he made the connection for me that got me the job working with David at the region. So, he's made a difference for me, certainly. Other people like Doug McCorkindale, Helen Galt, Carrie O'Leary, Ken Gosselin, Reno Radali, and a current colleague of mine I've worked with for many, many years, Bill Menzies in Winnipeg. And, they've all people I admire, all things that people I've learned lots from. I'm so fortunate to have some great peers to be able to work with over the years, Don Stevens and Rob Hunton and Heather Sanders, Steve Willis, many of you that are on here, Sean Doyle, I noticed was here, and Jeff Knopson. So it's been quite enjoyable. And then some amazing younger colleagues that I've been able to, work with and learn a lot from, quite frankly, over the years. I keep getting corrected by some of them on, my old guy terminology or whatever. And I've learned lots of good stuff. And I'm talking about people like Ian Borsick and Kim Hunton, Beth Garner, Deb Lightman, Kaya Sabag, Adrian Garreau, Marion Bello. They've all made a difference in how I've been able to enjoy the kinds of things that I've done. And I guess finally, gotta mention my family, of course. Wendy and I have been together for 44 years and married for 38, and it's a lot of things that I've been able to do and travel for and so on has been because she's been here in Ottawa and taking care of our three sons, who miraculously have all grown up to be people, and one of them's even in our business. Some of you probably deal with him on occasion. So, that's been very rewarding. So just wanted to say those things and kind of acknowledge some of the people, and certainly by no means is it a comprehensive list, but certainly I've had a lot of fun, and I'm very flattered to be considered and to receive this award, and just wanted to thank everybody. Thank you.
Thank you so much, Sean. That was really wonderful. Yeah, congratulations. I'm sure everybody here echoes that sentiment. Yeah, so thank you. Thanks everybody for that. Yeah, just congratulations, Sean. I think you were sitting not so much technically in this seat as I am before, but yeah, it's nice to kind of share at least partially on your journey. Since we do have somewhat of a captive audience, though, I would invite anyone at this time to think of something that maybe they would like to see in terms of a webinar that we could put on in the future, or an eventual luncheon, let's say. Maybe, oh, we have a hand up, Ben Novak?
Yes, if I may. Oh, my phone's ringing. Let me just take care of that. I would like to just add and see if Sean is still online, because I'd like to ask him a question. I was involved in the original study for mass transit in Ottawa, which was a Quebec-Ontario consortium that came up with the idea of the busway, which was at that time, I think, was very much in the favorite solution of the then transit manager, because we also considered LRT. I wonder if Sean would like to comment on that. That's all.
Sure. Yeah, I know the studies that you're talking about, and it's interesting that you mentioned the sort of the joint Ottawa, Gatineau, or Ontario, Quebec kind of connection, because that's still really topical today, right? And is an interesting subject on its own. I know that the transit manager you're referring to was also the regional government's, the regional municipality of Ottawa Carleton's uh, director of transportation planning at one point as well. John Bonsall is who you're referring to, and um, John was enthusiastic about bus rapid transit for the Ottawa market, largely because the flexibility, just all the traits that BRT provided, and at the time didn't feel that LRT would be appropriate for spending your dollars on. And the strategy they came up with at the time was kind of the outside in approach, right? Because when you're building LRT, you have to do what we've done here in Ottawa now. You have to spend your money, in the downtown, and build out from where your primary focus is. And what the transitways let them do is, for the same money, you get far more service by running from Baseline and South Keys and Herdman and Blair into the edges of the core, and then do those bus lanes that we had for so many years on Alpert and Slater. And the result was really successful, along with some other key policy issues. And you can't emphasize that enough. It's not just about the infrastructure. Around the same time, or just before the transitway construction decisions and so on really started, the region and OC Transpo convinced the federal government to move to what was at the time called flexible working hours. People could come in anytime between 7 and about 9:30 and leave anytime between 3 and what have you. And that spread out the peak. Up through the 50s and 60s, it was 9 to 5, and so that made a difference. So that combined effort with new infrastructure and some key policy changes about flexible working hours, another policy change about parking. The original former City of Ottawa, before amalgamation, put some policies in place to support transit as well, that essentially removed the requirement for parking from downtown high rises to be much more minimal than it might have been needed otherwise. And they also created a policy that provided a credit of 25 parking spaces per bus bay accommodated at a terminal. So Saint Laurent Shopping Center, for example, had different terminals at different times. The transitway station there, when it was first built, had 18 bus terminals, bus stops at it between the transitway level and the upper level. And so you think about that, that's 18 times 25 parking spaces that Saint Laurent didn't have to build. And if they'd had to build those, they would have been structured very, very expensive. So those kinds of policies made a difference, along with the infrastructure. Big long-winded answer. I'm killing time for John, I suppose, until Emmett appears.
No, not at all. Thank you. This is the most sensible and complete answer I've ever had. Thank you very much.
Oh, you're welcome.
All right. Thanks for that, Sean. Yeah, and I appreciate the thought that you did put into that. I have Emmett's presentation here. He is calling in. Emmett, are you on with us?
Thank you for having me at the CIT lunch webinar. Sorry about the delay in getting in here. I don't know what maybe the City of Ottawa has issues with the software. But anyway, the presentation is about the City of Ottawa's recent protected intersection design guide. Hopefully a lot of the attendees to this webinar, or the listeners to the webinar, will have had a chance to look at the protected intersection design guide that was published last fall. And and even had a chance to use it and to try to design some intersections with it. So I will give a brief overview and we can get into some details as well later in the presentation with questions. So briefly, what protected intersections? What are protected intersections? Oh, sorry, next slide. Forgot that I wasn't controlling it. What are protected intersections? So they are intersections, typically signalized intersections that provide dedicated space for pedestrians, cyclists, and vehicles at intersections. And what is unique about that is the dedicated space for cyclists typically, because previously most intersections didn't provide dedicated and protected space for cyclists. But the key features of a protected intersection versus maybe just a protected bike lane intersection with two-stage queue boxes is you have a corner safety island in the corner of the intersection, which protects a forward waiting area for cyclists, and that's adjacent to a pedestrian refuge. So they're placed advanced of the vehicle stop bar, and that both provides good sight lines to where the pedestrians and cyclists are waiting for the vehicles that are about to make a turn. And it also gives them a head start if they're waiting on a red light and the light turns green, they have a head start just in terms of distance to start their crossing before turning vehicles can kind of get to the conflict area. The cross ride and crosswalk are also set back from turning vehicles. So turning vehicles start their turn and then they are a little bit closer to perpendicular when they encounter the cross ride and the crosswalk. So that gives both time and space for the vehicles and the cyclists and the pedestrians to react to a potential conflict. And it also improves sight lines by getting that 90-degree turning angle. So those are kind of the key safety features. And functionally, what it allows you to do as you navigate the intersection as a cyclist is you are both forced and allowed and accommodated to do a two-stage left turn maneuver. So if you wanted to turn left, you cross the intersection, and then you wait in the opposite corner's advanced queuing area, and then you cross the intersection again. There's no confusion about whether you need to cross the lanes to turn left as a vehicle, and that is often a very difficult maneuver to make in a high-volume arterial or collector road context. So this makes it a very comfortable intersection for somebody that might not be a confident cyclist. Next slide. So why is the City of Ottawa building protected intersections? Kind of mentioned it on the last slide, but it combines best practices from the Netherlands and North America. It improves safety for vulnerable road users, just from some of those features that I mentioned, the cross-ride setback and various other features in the guide. But it also improves comfort and perceived safety of cyclists. So not only are they hopefully having a safer facility, but they feel safer as they cycle through the intersection. And that will ideally increase the cycling mode share throughout the City of Ottawa, as our facilities are seen as safer and lower stress, and that will attract the interested but concerned cyclists. So that's a goal and a vision of the 2013 Ottawa Cycling Plan, to provide low stress cycling facilities, and that's through the intersection as well. The guide was developed by Alta Planning and Design as our consultant. It also included Accessibility Simplified as a accessibility sub-consultant and Moon Map that helped with the traffic signal considerations. There was a extensive internal technical advisory committee and steering committee. We also reviewed a lot of applicable regulatory and policy documents, best practice review of guidance documents and academic studies and that sort of thing. We engaged with other cities, but didn't just kind of look at internally at the City of Ottawa, but also looked at the City of Toronto, City of Vancouver, the City of Fremont as well, who are all kind of leaders in planning and designing protected intersections. And finally, we did some observations at constructed protected intersections. That's an advantage that we had because the City of Ottawa had been building protected intersections for some years. So we were able to look at ones that had already been built and see what worked and what didn't. What and whether the protected intersections were working the way that we assumed that they would be. Finally, we did an on-site workshop with accessibility stakeholders. Next slide. And that was to look at how protected intersections were perceived by people with accessibility issues, but also to test various curbs that were in the built environment to see how detectable they were and whether they would work as kind of a consistent standard going forward in terms of delineation between the cycling features, the cycle tracks, and the sidewalk and pedestrian spaces. So here's somebody with vision loss, Kathleen, actually testing an angled curb at the Rideau Street cycle track. Next slide. So the contents of the guide. The guide is a framework for developing protected intersections. So it's meant to be used by designers, and it's organized into steps of the design process. Chapter 2 is guiding principles, and that is essentially what the City of Ottawa is trying to achieve for protected intersections, safety for vulnerable road users, low speeds at conflict points, those sorts of things, those sorts of key metrics and things to think about while you're designing an intersection are included in Chapter 2. Then Chapter 3, functional planning, talks about the context of the intersection. You want to identify, utility conflicts, where the intersection is in the truck route network, the transit priority network, and various contexts like that, and constraints that may restrict the ability to provide a certain protected intersection that you actually want and may need to compromise on certain elements or something like that. And then the next step in the process is identifying your corner radii for the intersection. And that's one of the most important things for designing the protected intersection, and to get right at the beginning of the design process, so you don't have to go back and redesign with a different corner radius. The bottom 3 images on the slide are showing a managed vehicle on the bottom left, that's a small passenger vehicle, a design vehicle in the middle, that's more like a heavy single unit vehicle or an articulated transit vehicle or something along those lines. And then in the bottom right is a control vehicle that you may allow to make that turn, but it can use a lot more of the intersection typically. And you can see in these images too that this is quite a large corner radius, and the pedestrian and cycling spaces are a little bit constrained in the corner. So ideally, if at all, we should be trying to get as small as corner radius as possible so that we can improve our pedestrian and cycling facilities in the corner and not kind of constrain ourselves to small waiting areas and poor kind of angles of crossing the cycle track and that sort of thing. When you have a large radius, you're producing a constraint right from the get-go. So getting a small corner radius as possible is really the name of the game for a protected intersection. Next slide. The next part of the guide, Chapter 4, is on protected corner selection. So once you have your corner radius, you know your constraints, you basically know the space you're working with, and you know your context. So you can choose various corner types that you might want to work with for the protected intersection that you're designing. This is just showing 2 of the 7 different corner types. These are probably the main ones. So on the left is a standard protected corner. It's unconstrained. There's a pedestrian refuge for the pedestrians to cross the cycle track and wait at the road edge between the cycle track and the road. And that just separates out the two crossing points and allows them to have a shorter signalized crossing. And then the cyclists can cross the pedestrians in a yield control kind of crossing and then get to that forward stop bar. On the right-hand side of this image is more of a one-stage crossing for pedestrians. So they would cross both the cycle track and the road at the same time in one signalized motion. But cyclists that arrive on a red light would have to wait behind that crossing. And it also makes a longer crossing for pedestrians. So there are some advantages and disadvantages to each of these options. But the image here, oh, sorry, next slide. I think you are forgetting to do that. We're at Chapter 5, Functional Design. This slide, the image on the right shows that there actually are, you can mix and match various corner types. So the top right corner is a one-stage corner, whereas the bottom right corner is a typical protected intersection corner. So both these corner types can be present on a single intersection. It really is dependent on the constraints of each corner, about what you can provide. The one in the southwest is a standard protected corner as well, but it might need a larger corner radius for whatever reason. Maybe it's on a heavier truck movement, and so it has that truck apron and a larger corner radius. So there's various different corner types that you can use on a single intersection. Chapter 5, Functional Design, is really the meat of the guide. It's broken down into pedestrian navigation and access, pedestrian safety, mitigating turn conflicts, bicycle safety and comfort, and transition. Next slide. So some of the key things that we wanted to provide guidance on were the pedestrian refuge size, which had been a subject of debate prior to the Protected Intersection Design Guide. There's now a standard depth in OTM Book 18 as well, and that was one of the documents, the draft OTM Book 18, that we reviewed for this guide. But we also just looked at how large it needed to be to comfortably fit somebody in a mobility device, where the accessible push button would need to be located, and those sorts of things, how to place attention twizzies on it, and came up with a minimum target depth of 2.7 meters. So there's a minimum depth for providing one of those pedestrian refuges. There's a little bit of guidance on the radii and when you might place a corner apron, and the materials that you possibly use for a corner apron. There is also guidance on cross-ride setback dimension, which is dependent on the corner radius as well. And we made it a little bit dependent on corner radius based on the work that the City of Toronto did, because if it has a smaller corner radius, the churning vehicles are going to be more perpendicular to crossing, even with a smaller cross-ride setback. So that allows some variation of the cross-ride setback based on corner radius. And again, just really that highlights how important the corner radius is at the beginning of the process. Finally, or not finally, but there's also bicycle turning radius, which was often, or not often, but sometimes neglected in some designs as doing an appropriate bicycle turning radius. So somebody cycling and making a right turn or a left turn through the intersection can make that movement without hitting a curb or having to dismount. And there's the typical, or the target size of the bicycle queuing area to hold a certain number of cyclists per traffic signal cycle, basically. Next slide. A heavy focus on the guide was accessibility considerations. You'll see that kind of repeated throughout the guide. We tried to make sure that it was a key message that you read as you continue through the guide and not just one standalone section. Bicycles are always meant to yield to pedestrians at these yield-controlled crossings. So there's bike yield to pedestrian triangles. There is the accessible pedestrian signal that we provided some typical locations, although that is always up to the final traffic signal design. But that just gives you a kind of an idea of where they might be placed. As mentioned, we tested various types of curbs, and the City of Ottawa landed on using half-height curb delineation between cycle tracks and sidewalks or pedestrian refuges. Excuse me. So that is a 60 millimeter height half-step curb half-step kind of barrier curb between the cycle track and the sidewalk. And again, between all cycle tracks and sidewalks, or cycle tracks and pedestrian refuges. There's the attention twizzies for crossing the cycle track and crossing the road, but a new type of twizzy that we're recommending in protected intersections that wasn't previously used in the road right-of-way is directional twizzies. If you ride the LRT, you may see them in stations, and they're meant to kind of guide pedestrians with vision loss or transit users with vision loss to key areas of interest, or the elevator, the accessible waiting area, that sort of thing in LRT stations. And in the intersection context, they're meant to indicate where the crossings are. If you're walking along, from west to east in this intersection, it indicates where the crossing is, and it also indicates what angle the crossing is at. If it's not at a perfectly 90-degree angle to the intersection, the directional views can help align you with the crossing direction, especially if it's a long crossing. That helps make sure that the pedestrian with vision loss doesn't, finds the opposing curb ramp at the other side of the intersection. Where the directional twizzies meet at the back of the two crosswalks, there should be an attention twizzy. They don't always meet, depending on the intersection geometry, but there should also be an attention twizzy square, which is a decision point telling you that there's two different routes you could take. Next slide. Another really important thing that has been identified in the predicted intersection design guide is a maximum taper angle, which is sort of like a minimum deviation in the straight path of travel for a pedestrian. The goal should always be to have kind of a perfectly straight path of travel for a pedestrian walking along the road and then crossing the intersection. But we know that through various constraints that can't always be the case. And in protected intersections in particular, because of the target cross-ride offset, so the cross-ride needs to be a certain distance from the road edge. And if you don't have a large boulevard on the approach, you need to taper the cycle track and the sidewalk further away from the road at the intersection. And so how do you know what the taper angle is? And we identified a 20-degree taper angle for the sidewalk. And that follows actually some similar guidance for the cycle track. They don't have to taper at the same angle, but they often do. So it's a 1 to 3 taper ratio, or about 20 degrees. And the back of the sidewalk should align with the center of the first twizzy that the pedestrian encounters. And so that helps somebody that has a cane maybe in their shorelining along the back edge of the sidewalk. Shorelining is a word that I learned through this process. With their cane, it will hopefully lead them to the crossing. And the directional twizzies, as already mentioned, will help identify the crossing location as well. Next slide. One other element that's included in the guide is it's not really entirely related to the protected intersection corner itself, but it's in the theme of improving safety for vulnerable road users, is centerline hardening. Centerline hardening is essentially providing a kind of a linear obstruction in the center line of the road for the road that you're turning from and turning into for left turning vehicles. And the left, it is intended to deter left turning vehicles from cutting the corner and at higher speeds, and exposing pedestrians and cyclists to risk through a higher portion of the crossing. With the centerline hardening, so it might be a rubber speed bump as a retrofit application, or it could be a mountable curb, or it could even be in large medians a full height curb. But it just forces left turning traffic to take a tighter radius and make the turn slower. And that's through research research and results in the city of Washington in the United States, and also the city of New York has shown very promising results in terms of safety. The city of Toronto is currently doing a pilot project on centerline hardening as well, so there should be even more results in the province of Ontario soon. Next slide. And finally, not finally, but I always want to say finally. Chapter 6 of the guide is detailed design. So we're past functional design, and there's some guidance on considerations for material selection, or more guidance on the directional twizzies and application of pedestrian guidance. Some recommendations for elevations and drainage, and considerations for road services for seasonal maintenance. included is a 3D sketch of a protected intersection corner, and that should just give you an idea of where all the various half-height curbs might be between the cycle track and the pedestrian areas and how those are developed. And also a sample drainage pattern, providing drainage to curb inlets at the road edge and also curb inlets between the sidewalk and the cycle track, supplementary curb inlets. Now that is just an example, though. There could be other solutions, and the supplementary curb inlets, we don't currently have a standard for those as well, and you can provide all drainage to just one catch inlet at the road edge. That would, of course, be a lower cost solution. So that's something that should be looked at. But in the 3D view, you can see, at the corner safety island, you have full height curb to really protect the cyclists and the pedestrians in the waiting areas, and you have those half height curbs between the pedestrian refuge and the cycle track, and you have various ramping up and down for both the pedestrians and the cyclists, and how that drainage would work. So I find this image quite helpful for understanding how all these elements come together at the corner. Next slide. A very important part of the guide that was perhaps not considered early on in some protected intersection design was how the geometry of protected intersections, which does help in terms of lowering the risk of turning vehicle conflicts through the cross-ride setback and through some of the features that we've already talked about. But that is meant to be paired, the geometric considerations of protected intersections are meant to be paired with signalization measures as well. So if you have a really high volume of right turning traffic across the cross-ride and the crosswalk, you are going to want to consider protected turning phasing to separate the right turning traffic from the pedestrian and cycling crossing in time in the signal phasing. So that may take the form of just a leading pedestrian interval or a leading bicycle interval for an extra head start in the signal phasing plan. Or it may be a permissive green ball with a right turn overlap phase going at the same time as a protected left turn in the cross street. Or if there's a very high volume of right turning traffic, you may even consider a fully protected right turn phase. So right turning vehicles can only go when the pedestrians and cyclists are not going. The requirement for protected turning phases is based on turning vehicles. It's not based on the number of cyclists or the number of pedestrians. And that is because as the number of cyclists and pedestrians gets lower and lower, there just really isn't much correlation between the risks that they encounter versus a higher number of cyclists and pedestrians. At least that's what we found when we were doing our background research and review. However, conversely, then the higher the number of turning vehicles, the higher the risk. The more there is a sort of a follow-on effect of vehicles kind of following just directly behind the vehicle in front of them and trying to kind of squeeze through. And that's maybe a bit conjecture, but nevertheless, the guidance is clear that the higher the number of motor vehicles turning is when you really want to consider protecting your right turn signal phasing. And the requirement for protecting signal phasing, both left turns and right turns, is a little bit more strict when you have a bidirectional cycling facility. So that's something you want to consider along a corridor. If you're considering a bidirectional cycling facility, the requirements for right turning, for protected right turns and protected left turns will be higher. So you may need to provide more right turn lanes and more left turn lanes, protected right turn lanes and left turn lanes and that sort of thing. So that's sort of an argument for more unidirectional cycling facilities. Next slide. So the Protected Intersection Design Guide has been out for several months, and the people have been using it. Many people who are listening to this probably have been using it as well, and maybe are old hats with everything I've just been talking about. But some design issues or just design challenges that we've encountered even since the Protected Intersection Design Guide has been out, I'll go through in the next few slides. So one is the need for right turn lanes. I really went over it just that one slide ago. But if your number of right turning, if your right turning volume is high, you might need protected right turn phasing. To have protected right turn phasing, you need a right turn lane. And so we really want to protect for the ability to have protected right turn phasing if the right turn volume is very, very high. In the past, if the volume over capacity, if the capacity of the intersection was working okay with two through lanes and the right turning vehicles would share, even if it was a high right turn volume, would share one of the lanes with one of the through volume. And if that was what's functioning okay from a capacity perspective, then that was all right, even if it, sometimes of the day it might even function as a de facto right turn lane. However, that just doesn't allow the protected right turn phasing. So in this design, it started out with two through lanes and one of them being a through right lane. And because that right turn volume was so high, a dedicated right turn lane had to be added to allow for that protected right turn phasing. Rather than just adding a dedicated right turn lane, you may want to consider converting one of the through lanes into a right turn lane to reduce the number of lanes to cross if the volumes aren't too high. So, just having a single through lane and then a dedicated right turn lane and a dedicated left turn lane, something along those lines. But here the volumes were high enough that we couldn't do that, and we had to provide another lane. Another element actually with these two designs is corner radius. So the first design, if you look at the westbound right, that was designed with these are an arterial with a truck route, and it was designed with a WB20 straddling the through lane to make that turn to try to tighten the corner radius as much as possible. And that is encouraged. However, the right turn volumes were high enough that we needed, or we're likely going to providing a permissive protected turning movement. So there's going to be a phase where the westbound right turn goes at an overlap with the southbound left. And what that means is, if you consider your phasing, and a truck is waiting in that right turn lane, it is going to need to go during that overlap phase, and it's going to need to start its turn from that westbound right turn lane. So the design was changed so that the westbound right turn, or the WB20 started its turn from that dedicated turn lane, and that increased the corner radius in the image on the right. And the truck apron was added as a mitigation. So the whole point of all this, trying to get out of the details, but the point is that you need to use your volumes to determine whether you need protected turn phasing, and then do you have the sufficient number, like you have sufficient right turn lanes to support that turn phasing, that desired signal phasing. And then that feeds into what your parameters are for your control and design vehicles in terms of where they start their turn and end their turn. And that plays into your corner radius. So it's a bit of a feedback loop that you have to work with at the beginning of your protected intersection design to hit that ideal corner radius and lane arrangement. Another thing that still seeing is not applying minimum cycle track corner radiuses, especially at the early functional design stage. This intersection, sorry, next slide. This intersection, you can see it just has right angles on the cycle track at both the right turn and the left turn. And you may think, well, at the functional conceptual stage, it doesn't really matter. We'll fix that in preliminary details. But at this intersection, if a radius was applied for a left turn, for example, you lose most of your corner safety island, and it may not be an effective corner safety island anymore. You might have to reposition your cross rides. You might not be able to fit traffic signal infrastructure. So that can be a real challenge. So applying those radiuses right from the beginning, right from the functional design stage, gives you a more realistic outlook to how the intersection is going to fit. Next slide, last slide. The last thing I want to mention is that the Protected Intersection Design Guide mentions ideal corner radiuses, both for motor vehicles, or for motor vehicles, and those are really just ideal. You really should be using auto turn for arterial intersections and collector intersections with turning parameters, mostly based on the Toronto curb radii guidelines. So the ideal is not what you have to use, because it is mentioned in the guide. And similarly, the Pedestrian Refuge has a target depth, but that's just like the minimum target. In the left design, I believe that target was used to sort of design the intersection. So each pedestrian refuge is only about 3 meters wide. But the incoming sidewalks were at the back of the right-of-way. So the sidewalks bent in to to accommodate a target refuge of 3 meters. But in the potential improvement on the right, you can increase your pedestrian refuge size to, 4, 5, 6 meters deep and create a straight path of travel for the pedestrian as they're going through the intersection. So that's a potential improvement, and just a note that you can vary your pedestrian refuge depth as needed. And that's the end of the presentation. Sorry, I took so much time at the end of lunch hour now for questions.
Thanks so much, Emmett. Awesome presentation. Really appreciate you coming out and giving that to us. I don't see any questions at the moment. I mean, we only have like a minute or so here. Oh, we have one question. Are there provisions for carrying a MUP across the intersection as a MUP? I think it was added to the OTM Book 18. It doesn't seem appropriate to split up a MUP approaching an intersection into separate crosswalks, cross rides, recombine them on the other side. Do you have thoughts about that quickly before we go?
Yeah, so the draft policies for the new TMP include considerations for where multi-use pathways are appropriate, and one of those considerations is the frequency of signalized intersections, just because the splitting and recombining of multi-use pathways at signalized intersections can be a bit of a challenge, a bit confusing for all users. So I definitely recognize that. Especially at higher volume multi-use pathways, when you approach an intersection and it's on a red light, you definitely want kind of separate waiting areas, or at least a larger waiting area for pedestrians and cyclists to wait before crossing the intersection. But whoever asked that question is correct. There is a provision in OTM Book 18 for combined cross rides and keeping kind of combined waiting areas at intersections, and that may intuitively be appropriate at very low volume multi-use pathway, like low user volume multi-use pathways, maybe in the suburbs or something like that, where you're unlikely to get large numbers of users waiting and conflicting at the crossing. Awesome. However, the City of Ottawa has not been able to confirm the appropriate locations for accessible pedestrian signal push buttons, and a few other considerations that when you get to the detailed design of the combined cross rides and the multi-use pathway approaches and intersections, or the signal infrastructure and a few other aspects to provide combined cross rides. So we're not recommending combined cross rides at this time, and that's why we're recommending splitting multi-use pathways. We are continuing to look at it though, so it could be an option that does present itself in the future, but at the moment it's not something that we're recommending.
Awesome. Thanks for that comment, Colin, and thank you again, Emmett. I guess you have your email address here if for question, or for I guess contact information in case there's any needs, I guess, that you have about that. So thank you again so much. Thank you, Sean Rathwell. Congratulations again, and thank you to everyone for coming out and being with us today. Thank you. Take care.